Hello guys, welcome once again to my YouTube channel. Feel free to join, subscribe, like and share. Today I want to talk about product rule used in differentiation. I'm going to derive it and use it to solve some differential questions. Feel free and welcome. So this is it, product rule, and product rule is defined as the following. If I have a function of f and g of different functions which are differentiable, functions, then their derivative of the two products with respect to x, a function of x and a function of g, using product rule, then this is going to be, I'll take a function of x and then I multiply by the derivative of a function of g and then add it to function of g multiplied by the derivative of x. That is what product rule simply means. This equation can also be written as if I have a function of d of x, a function of f and g, then this just taking the function of f multiplying by the derivative of g with respect to x, add function of g multiplied by the derivative of x. So this rule is very simple. We can prove it. So I can prove it using the first principle. From the first principle, I'll take the derivative of my two functions, which is a function of x and a function of g, and then I'll introduce limits using the first principle equation. So limit as x change in x goes towards 0, a small change in x goes towards 0, of f of x plus a small change in x, g of x plus a small change, that is g of x plus a small change in x, subtract my equation, that one, and everything of a small change in x. So for me to solve this equation, I'm going to add and subtract certain terms in this numerator. So if I'm adding, so my numerator is here, I want to try adding certain terms, then by doing that I'll factorize. So I have f of x plus a small change in x, g of x plus a small change in x, minus f of x, g of x plus small change in x. I've subtracted this, and then I'm going to add the same f of x, g of x plus small change in x, subtract f of x, multiply g of x. I can now factorize what is common outside. By factorizing means I have here f of x and here f of x. I also have the small change in x here, and you also have a small change in x here. So factorizing, I'm going to have f of x plus small change in x minus f of x. I've taken this one and this one, and also taken this one and this one outside. What remains is g of x plus small change in x plus, on the other side, this side, I can factor out f of x. I'm going to remain with g of x plus small change in x minus g of x. I've tried factoring out. On this side I factor out x. So introducing my limit, then limit as small change of x goes towards 0 of f of x plus small change in x minus f of x change in x. Remember, here I have g of x plus small change in x. I've just taken the limit of this side. I want to add the limits of this side. Limit of that side is limit as change in x goes towards 0 of f of x multiplied by g of x plus small change in x minus g of x also over change in x. So I'll do this one and this one separately, since I'm adding the two. So on the right hand side, on this side I'll have we remove this one. I'll have limit as change in x goes towards 0 of f x plus small change in x minus f of x all over small change in x g of x plus small change in x plus the limit as small change of x goes towards 0 of f of x find then g of x plus small change in x minus g of x all over small change in x. I know from here f of x does not depend on small change in x, this one. So if it doesn't depend on small in this one, then my equation now will change to f of x of the two function is the same as f prime of x, g of x, add f of x, g prime of x. Remember this one, the whole of this here is the derivative of x, and the whole of this one here is the derivative of g. So I was saying this one is the derivative of x,